everyone. I am Doug Clark, the director of the Center for Near Eastern Archaeology here at Al-Saad University. And it is a privilege to welcome you who are here and several people who are on Zoom and who are on live stream. So we welcome all of you to this is the inaugural Winter Archaeology Lecture. As you know, at least as many of you know, the Center for Near Eastern Archaeology sponsors an autumn event. We are going to be having our 14th annual event on the 12th and 13th of November of this year on the Egyptian pharaohs, the ancient pharaohs, glory, grit, and grandeur. So be sure to be watching for announcements about that. And then in the springtime, we normally have a lecture or a series of presentations during homecoming weekend. And this year, it will be on April 30. The university is celebrating its 100th anniversary, and the Center for Near Eastern Archaeology is celebrating its 10th anniversary. So we're looking forward to that. And the presentation will be provided by several people on a history of archaeology at Al-Saad University. So you'll want to be watching for those sorts of things. Please let us know. You can go to our website, and if you have any questions, ask us about those. It's also my distinct privilege to be able to introduce our inaugural Winter Archaeology lecturer, Dr. Ziad Al-Saad, who is a former Director General of the Department of Antiquities of Jordan, who is a professor at Yarmouk University in Irbid, Jordan, in the north, and who has been so far this year and a few more months also the annual Fulbright Fellow at Al-Saad University. And it's just been a privilege to have you on our campus and to have you teach a course for us in the autumn. A couple of housekeeping items. I will be monitoring the Zoom exchanges, communications. So if you have a question, send it via Q&A or the chat, and I will pay attention to those. And then I will also be repeating the questions. This may sound like you'll hear it twice if you're in one place. Otherwise, the people in another place won't hear it at all. So we will be repeating all of the questions, and all Dr. Ziad has to do is answer the questions. So welcome to our campus. You've been here for now several months, but welcome to this inaugural Winter Archaeology Lecture.
Thank you very much. Thank you. Good evening, everybody. So the privilege and the honor is mine, Douglas, just to be given this opportunity to start the Winter Lecture Series of CNA is really a great honor and a great privilege. I would like, first of all, to thank the organizers of this event, particularly my close friend, the director of CNA, Professor Douglas Clark. Thank you very much for everything you have done for me. And because of you, I'm here at Al-Saad University. As you know, that I'm on a research visit to the University of Al-Saad sponsored by the Fulbright Foundation. This is through their Visiting Scholar program. I'm grateful for both the sponsor and definitely the host university, Al-Saad University. I'm so delighted that I will speak today to a distinguished audience about an important aspect of the history and archaeology of my country, Jordan. Jordan is a birthplace of civilization. Its sites serve as an important reminders of the importance of the intersection of historical, cultural, and community values. Today's presentation focuses just on one aspect of the Jordan history and archaeology, the role played by ancient Jordan in the technological achievements and advancements of a human being through great interventions. And these interventions are considered now as turning points in the history that change people's life. So, interventions go to the inventions, I'll just give you a very brief idea about Jordan archaeology and cultural heritage. So Jordan is a land steeped in history. It has been home for some of the mankind's earliest settlements, and many of the world's great civilization relics can still be seen today. So you can ask the archaeologists who are more experienced in Jordan archaeology than myself. We have here Doug, Larry, Kent, Sean, they're all involved in Jordan's archaeology. As the crossroads of the Middle East, the lands of Jordan have served as a strategic nexus connecting Asia, Africa, and Europe. And as you see, the strategic location of Jordan and maybe also the climate of Jordan, the mild climate of Jordan has been given Jordan the edge in order to be constantly settled throughout every single period of history. So the country is really endowed with the wealth of cultural resources. And maybe Jordan contains one of the highest concentration of cultural heritage sites in the world. So we have over 100,000 archaeological sites that have been identified so far, more to come. 25,000 of them are on the national database Mega Jordan. So it's Jordan heritage, which lends the country the unique characteristic of an open air museum. So Jordan didn't earn the title of an open air museum for nothing. It is really a title well earned. Empires have crossed this land and left their mark, from Greeks, Romans, Byzantine, Persians, Crusaders, and Muslims. I'm just showing some of these majestic sites in Jordan. Of course, you all recognize Petra and some of these monumental Decapolis cities. And that's the last visit of Prince Charles to Jerash, Gadara. I was really privileged to accompany him during that visit. And I'm just particularly want to point out this amazing mosaic floors of St. Stephen's in Rasas, one of the most important, significant sites in Jordan. Now to the topic of today, creativity and innovation. I just selected three items, three topics to be presented today. I could have added to this list more, but I selected the three which I consider really a real turning point in human history. The first one is the lime plaster production. And second one is smelting of copper. And the third one is the water engineering and management. Lime plaster. Why lime plaster production is important? Most Paleolithic inventions and technologies were in the form of tools and weapons. And these tools and weapons were made of natural material, naturally occurring material, stone, wood, and bone, using only mechanical means, which means they didn't change the nature of the material. They only changed the form of the material by using, different mechanical techniques to produce their weapons and tools, particularly by using flaking to produce these sharp points and edges on the spears, for example. So they produce their weapons and tools by using mechanical means. And it is until the discovery in Jordan, in Ain Ghazal, I will talk about Ain Ghazal later, but discovery of the first use of a chemical process to produce a man-made material. It's not a naturally occurring material, which is the lime plaster. Lime plaster didn't exist in nature. We have limestone. Now, in order to transform limestone into lime plaster, this is really a complicated chemical process. So plaster was produced by using an alteration process, chemical alteration process. So the first use of lime plaster, as reported by archaeologists, is about 12,000 years ago at some of the Natufian sites. But that was only initial carbonation, partial carbonation, not full, lime plaster, with a very small scale. Now, the first large-scale lime plaster production and use was really at Ain Ghazal. Ain Ghazal is a site in Jordan. So that site was extensively researched by a joint project between an American university, I think Whitman College with Gary Robertson, and Yarmouk University under the leadership of Ziad Kafafi. So that was about 9,000 years ago. Earliest example of large-scale lime plaster production was found at Ain Ghazal. So they found plaster extensively used to cover floors, walls, as you will see here. So that large-scale production was not just confined to the use of plaster as an architectural material, but they used it to produce statues. A very unique statues, very famous in the world now. Ain Ghazal statues are being exhibited in different international museums like the Smithsonian Museum, Louvre, and the Jordan Museum. We have a couple of them at Yarmouk University Museum. So this is, as you see, lime plaster used for these rounded houses and also used for the production of these strange statues. And these statues, I'm not going to talk about their spiritual meaning and symbolism. I'm talking about the technology aspect today. Okay. These are considered the world's oldest known large-scale statues that are dated to about 9,000 years ago. So now 9,000 years ago, they used a man-made material. It's not a natural material. They use some natural material for the production of the statues. They use reed and they use bitumen. Bitumen from the Dead Sea and the reed. But the most important material they use is really lime plaster. And lime plaster they have to produce. So the statues of Ain Ghazal have survived for 9,000 years to tell us about really human ingenuity, spirituality, and technology. As I mentioned, they used some local material, reeds abundant at the site. They used bitumen to draw the outline of the eyes and the irises, but also they used lime plaster. They couldn't really produce such statues using limestone. Very difficult to shape limestone like they did with the lime plaster. So the production of lime plaster is really especially important as a technological development in the human prehistory. It requires advanced knowledge, skills, and knowledge in the nature of the materials and how you can alter and change the nature of the material by applying heat. This is what they did. And they transform rocks to a plastic yet durable material to produce the statues. And if you just follow the chemistry of the lime production cycle, you know that these people were really advanced in their knowledge about the materials. So they knew that they have to decompose the calcium carbonate, which is the main chemical of the limestone, decompose it by applying heat to about above 800 degrees centigrade to produce lime, calcium oxide. And this calcium oxide, when added, when they added water to it, they produce what they call slate lime, the body that they can really use to manipulate and shape. Okay, but this also needs an extra step for setting up what we call the lime carbonation in order to come back to be a calcium carbonate again and achieve the durability. So it's a three-step process. They need to heat at a high temperature, decompose the calcium carbonate, and then add water. They know that there will be a reaction between water and lime to produce the calcium hydroxide, which is what you call the slaked lime. And then they lift it to take CO2 from the atmosphere, from the air, in order to complete the cycle and come back to calcium carbonate. So you think that this happened 9,000 years ago at the site of Ain Ghazal. So you can imagine what level of knowledge that these people had at that time. The second innovation that I want to speak about is really what's considered now by many archaeologists and many scientists as the first industrial revolution. First industrial revolution happened in Jordan. So what this industrial revolution all about? It's about transition from Stone Age to the Metal Age. Before copper smelting, stone was the primary material for a human. This is what's available in addition to bone and wood. But they use the stone. That's why we call it the Stone Age. And now a critical turning point in history was when humans began to use or to produce metal. What was the challenge? The challenge that metal in general doesn't occur in nature as a free metal, except gold. Metals, they exist as compounds, what we call them ore, which means the metal is combined with other elements. So that's totally different from the metal in terms of its chemical and mechanical properties. So the technological innovation was really to transform these ores into metals. We'll see how complicated, how sophisticated that this process can be. Now, the first and the earliest indication of production of copper, the first metal produced in the Metal Age, comes really from a research done by a Canadian team from University of Waterloo in Canada, who they have been studying the area of Finan in southern Jordan for about 25 years. And they discovered that this dry riverbed is contaminated with copper metal. And they used carbon-14 dates and other dating tools to estimate that this was about 7,000 years ago. At the very beginning of the Chalcolithic, maybe period, a little bit, maybe even earlier. So the scientists found this evidence of early pollution caused by combustion of copper. And we think that an indication that copper was produced at Finan, because native copper, although there are some small quantities of copper can exist in nature as a native copper, these are very small, very tiny. Most copper is really man-produced by smelting from ores. Although really the name of copper, as we discussed with Doug the other day, derived from the name of Cyprus, and archaeologists believe until this discovery and other work, I will mention the research also done by other research teams who have been working in Finan for over now 30 years, that the earliest evidence of copper smelting was from Mesopotamia. And they estimated that at about 6,000 years ago. Now we have this evidence that the earliest evidence of copper smelting was really actually from Finan, not from Anatolia, not from Mesopotamia, not from Egypt. These are the three places thought before that they are the birthplace of copper smelting. Cyprus, by the way, although it's very famous because of the name, they started smelting copper at 2500 BC. That's, you're talking about 4,000 years later. So when I gave a lecture it was not this lecture, but there was a lecture about archaeometallurgy at the University of Cyprus. And when I mentioned this information, they got stunned really by the idea that Cyprus is not the birthplace actually of copper smelting. The birthplace of copper smelting was really Finan area, which is about 50 kilometers southeast of the Dead Sea, and contains one of the largest sources of copper ore in the Middle East. And I'm here summarizing the research findings of three big projects. The German project, what we call it, German Mining Museum at Bochum. They started in 1983 under the direction of Andreas Hauptmann. Also, there is a United States project, UC San Diego, and our friend Tom Levy, who have been working really in Finan for a long time. And also, there is a British project, the Wadi Finan project. And just to give a summary of what they have now, almost like a consensus on these facts, that people of Finan about 7,000 years ago, earlier than anybody else, anywhere else, they discovered copper ore, possibly by accident because of the colors. The ore could be heated to a very high temperature in a low oxygen environment to melt out to pure copper. We'll see. So mining and smelting continued uninterrupted until the 4th century AD. Of course, it reached some peaks during early Bronze Age, Roman period, and particularly in the Iron Age, the 10th and 9th century BC. Now, the indication of the scale of production of copper is really what left behind, the slags, what we call, which are the byproduct of the smelting process. And people can do really easily, can back calculate the amount of copper produced based on the slags. So we have slags, slag heaps. It's like they are like amounts of slags, about 2,000 tons now at the site. You see the ore everywhere, the mines, and also later on the Bronze Age, they discovered what they call a bronze factory, because they produced copper ingots and bronze at an industrial scale for export. Just briefly to tell you what it takes to get copper from its ore. Copper ore to copper metal. This is not easy at all. This is a very sophisticated and complicated process. It's a multi-step process. We have at least 4 physical, what we call physical processes, and at least 3 chemical processes in order to convert copper ore into copper. They have to collect the ore from the mines. At the beginning, they can do what we call pit mining or surface mining, but later on they have to dig deep. Okay, they have to dig deep to get the ore, and then they have to do some sort of a preparation of the mine by beneficiation and refining to get as much as they can rid of gangue material and impurities. A lot of it, because even the best grade of copper ore can contain not more than 10 to 15% of copper. But the most amazing thing is not really the physical processes or the chemical processes, especially the smelting. And people sometimes they mix between smelting and melting. So melting is a very simple process of converting a solid substance into liquid. Smelting is something else. It's an electrochemical process. It's a reduction happened. You apply here temperature, and you have to have a reducing agent in the atmosphere in order for this process to be completed. So copper production was really a complex process. Nearly every element of the process, from mining the ore to refining the finished copper, required deep knowledge and understanding of the nature of the material. We'll just focus on the smelting. So copper exists in nature, as I mentioned, copper ores, like these compounds. And in Finan, the most predominant ore is really chrysocolla, what they call the copper silicates, and the malachite, copper carbonate, with some chalcopyrite, which is the copper iron sulfide. That's very hard to work, really. Very hard to get metal copper from chalcopyrite, but they did it also. So smelting is a chemical process. In order to extract copper from its ore, you need to have really certain conditions, certain requirements. The first one is really the very high temperature. And we'll talk about the temperature and how they control and manage the temperature. And then they need also to have a reducing atmosphere. And also, they need an extra, very sophisticated thing for purification. I will talk about that later. So if you just look at the chemical equation, this is a malachite. Under heat, you can, in roasting, that's an open pit, you can do this. So you got oxide, copper oxide. So copper oxide, in order to take out the oxygen from the copper, this is a very strong bond. You need a very high temperature, and you need an agent, a reducing agent, which is the carbon or carbon monoxide. So this journey from ore to metal is a very sophisticated and very complicated one. If it is chalcopyrite, you go to this series of complicated chemical reactions before you can get copper. I'm not going to the chemistry at this stage of the reduction, but some people thought that smelting might, have been discovered by accident, maybe began as a result of accidental cooking of metal ore in a campfire. Is that an accepted argument? No way, because with that sort of fire, you cannot get the high temperature you need for the roasting and the smelting. And also in the presence of oxygen, even if you got 2000, temperature of 2000, not centigrade, you end up with nothing because of the presence of oxygen. You need a reducing agent. You need a very saturated atmosphere of a reducing agent, in this case, the carbon. So most probably, it's not yet a fact that smelting maybe was happened for the first time, discovered in a pottery kiln. Because in a pottery kiln, temperature might get really high. And sometimes in some corners of that kiln, if you get an ore, you might get a localized reducing agent, reducing atmosphere, sorry. So the requirement of smelting of copper is a very high temperature. You need 1200, at least 1200 degrees centigrade. That's about above 2000 Fahrenheit. You need a chemical reducing agent to decompose the ore. And here they have to use a fuel that can give them the very hot temperature and the reducing agent at the same time. So they use charcoal instead of wood. And you need what we call the flux. What's a flux? And the fluxing is really, for me, still puzzling how they really found about this flux. Because if you do the reduction, and you have a furnace, temperature, reducing agent, everything, you end up with a very complicated mixture of molten copper, but with a lot of gangue material fused to the copper. And this cannot be separated. No way. So you got the copper, yes, but the copper is not obtainable in this case. They really found, I don't know how, that if they added what they call a flux, which is an external substance, they add it to the furnace or to the pit. At the beginning, they use a pit furnace. In this case, it's an iron oxide. It can react with the silica and form a molten phase that can be easily separated. So this is another chemical process. So look, they have to manage the temperature, and 1200 is not an easy temperature to manage. You need a special construction of the pit furnace that they used at the beginning, and with a good air draft. And also, they need to control the ore charcoal ratio in order to maintain the reducing atmosphere in the kiln. And above that, they have also to use the flux. These are the three basic elements needed for having a successful smelting process. How these people managed 7,000 years ago. To have all that knowledge is really very puzzling. There are so many theories about how it might really happen, but still there are theories, not, facts. So you look to the ingenuity of the fluxing process. This is the copper. When you got the molten copper, it's at the bottom, okay? Now with the addition of slag, of the flux, you got this molten phase, and it is less dense than the copper, so they float above. And then they open the vent to tap the slag out of the furnace. And we have really here, as you see, the running slag. All the slags are of that type. There are some what we call cake slag, which are slags maybe with a small scale of production of copper, but with a large scale, they needed really to have this process, the flux. And most of the slags are really of these tap slags. The refining of copper, in particular, the smelting is really a very challenging chemical process, but the refining was a high tech of that period. There was no technology more sophisticated than that in the whole world, the whole of the ancient world at that time. Nothing like that. They had to discover the flux. They have to select the flux, which means the chemical substance that can do the trick. React and create that phase which is less dense than the copper itself, so they can be separated. So I think it deserved to be an industrial revolution, because that process, changed the course of history. From Stone Age, now we entered into the Metal Age, the Bronze Age. The third area of innovation that I want to speak about is really the water engineering and management systems. And here, Jordan suffered from the scarcity of water, particularly these days. We are the third most water scarce country in the world. But how our ancestors managed to have a permanent resource, permanent supply of water, because without managing water in that way, how we could imagine all these cities and civilizations that really flourished in Jordan. So I call it creativity force by nature. Nature not being so kind to Jordan. We have no rivers, no springs, almost no water. We have good rain this year, though. But water harvesting is really poor in Jordan. So the people who settled in Jordan were able to create for themselves a near permanent water supply in places where nature was not kind. Several insights of Jordan, they provide examples of this hydraulic engineering creation in some very really dry area with almost very little rain, very little. I'll mention to you 3 examples of real innovation on water management. The first one, the world's first dam. This is the Al-Saad Dam, now well documented by many really scientists and hydrologists. This is the Jawa dam located in one of the driest areas of the Black Desert of Eastern Jordan. We call it the Black Desert because of the basalt. It's covered with basalt. Why Java is so important, I'll let you know. So Javadam was constructed about 5,000 years ago. It's in the early Bronze Age almost. And that was part of an elaborate water system established in the middle of the desert. And then after this system, they managed to have a city in the middle of the desert with about 2,000 inhabitants. And the relics of the dam, they still exist until today. Okay. Javadam site is arguably the most important archaeological site in the history of large-scale water projects. Why is that? Why hydrologists think that this is really an exceptional dam? Because of its age and because of something else, because of its construction technique. This dam was built using modern-day dam technology and engineering. The design and construction of the dam is really amazing, that they could, if you look to the design and the structure, you will see that this is a dam built with a great knowledge of especially the water back pressure. This is an important aspect of dam building and dam engineering. So they built it of 2 dry masonry walls, enclosed an earth core of about 2 meters. And additionally, an impervious blanket was provided in the form of an upstream hill. So they created a stable structure and they protected the dam from the dangers of water back pressure, which we think, the hydrologists, not myself, because I'm not an expert in this field, they think that this is a precautionary measure that was reinvented only in the modern times. Most of the known dam examples are of simple gravity dams. This is the only one with that sort of sophisticated engineering, dam engineering. Now, for unexplained reasons, this miraculous desert city collapsed as swiftly maybe as it rose. It might even have become a victim of its own success, because archaeologists think because of so many people putting a lot of pressure on the system, so it collapsed altogether, because the city lived for some time and then completely deserted all of a sudden. So again, there are some explanation of the construction design and the engineering of the dam. The second water system, second example, is sophisticated water technology of the ancient Nabateans. Petra, that's the most famous, maybe, water system in the world. You all know about the mysterious Nabateans and their kingdom, the very powerful and flourishing kingdom. For about 600 years, the Nabateans, they managed to establish really a very powerful kingdom, with their capital Petra was the hub of a trade for caravan routes. Because of many reasons, because of many values associated with Petra, either technological and otherwise, human values, Petra was inscribed in the World Heritage List in 1984, 1985, and then was chosen one of the new 7 wonders of the world in 2007. We can talk about Petra, a city altogether, cut in rock, from rock. We can talk about the Nabatean trade. We can talk about many aspects of the Nabatean civilization. For example, the pottery technology, their eggshell pottery was really quite an innovation as well. But today I'll talk only about the water management technology. Considering Petra desert location, water resources were of utmost importance to the city. Establish a city in the middle of the desert. This is not an ideal place for establishing a city. But Petra was the capital of the Nabateans and the capital of trade in the period between the 4th century until the 2nd century AD. It was a caravan city, so you need a lot of water. But they Nabatean managed their water resources masterfully, as indicated by the highly developed water management infrastructures around the city. You can find many of these elements of that system still available. Also, Nabateans faced another challenge. Okay, they want to have water, but also they have to protect their city from the potentially damaging and deadly flash floods. And these flash floods really were a big challenge for them, as they are still a big challenge for us today. Last flash flood happened in Jordan, 2018, killed 11 people, and forced the evacuation of nearly 4,000 tourists from Petra. So they collected every single drop of water, and they protected their city by building this water management system. It's really, Petra is home to an incredible feat of hydraulic engineering. You can see this extensive water supply system, management system, and distribution system as well, everywhere. I'll show you some of the elements. So we think, based on the analysis of study and analysis of lift structures, that Nabateans really had a remarkable understanding of hydraulics, how to design sophisticated water systems, how to build, for example, dams and cisterns, a system that really contained many elements, building flood control systems, building pipelines, channels. So managing all these elements, interdependent elements, and provide a continuous year-round water supply to the city is really very crucial for the understanding of how sophisticated and how advanced these people were in water management hydraulics. So if you visit Petra, you can look at some of the remains of this water infrastructure system: terraces, channels, setting basins, aqueducts, dams, rainwater harvesting, flood harvesting, groundwater harvesting systems, large range of size and types of systems, reservoirs, and many other elements. The channel system, for example, the pipelines that they created for the distribution, that's another amazing thing. So they designed a system that maintained this stable flows of water, and they use sequential, what they call particle settling basins, to purify potable water supplies. So they applied a sophisticated knowledge in order to solve complex hydraulic problems, especially related to control the flow and to control the capacity, the carrying capacity of their system, especially the pipelines. That needs really a very meticulous work and accurate calculations. So if you go to see some of these pipelines, they look like produced today. Now, the ingenuity of the system is really of this design, the diameter. So they calculated really everything. They calculated the water flow, and they calculated the internal roughness, diameter, slope, and many parameters and many variables they have to control in order to make that sort of design, especially in order to calculate and manage the carrying capacity of the system. Okay, with the water scarcity and considering the desert environment in which the kingdom was located, it seems only logical that Nabateans would be parsimonious with their precious water resources. By contrast, archaeological excavations and studies revealed and some examples really, or several examples of extravagant use of water in the city. They had swimming pools, gardens, and they have really water available for their domestic use, but also for recreational use. The third and last example that I will present to you is the Gadar Aqueduct, the ancient world longest water aqueduct system. What is Gadar Aqueduct? This is a tunneling system aqueduct that was built to supply water to the Decapolis region, which is the League of 10 cities, Greek-Roman cities. 7 of them are in Jordan, present-day Jordan. Because again of the scarcity of water, they built that system to bring water from Syria to Jordan. So this system, this aqueduct started from a lake in northern Syria. Actually, not northern, it's almost southern Syria, around Damascus. So the aqueduct runs above the ground in Syria for about 60 kilometers, and then disappears into 3 tunnels in Jordan. So in Jordan, the whole system is really underground, with length of 111 and 94 kilometers. The longest section is 94. The total is 170 kilometers. But the longest continuous section is 94. This 170 kilometers is about 105 miles. Pipeline is not only the world's longest underground aqueduct of the antiquity, it's also the most complex and represents a colossal works of hydroengineering. I believe that in terms of construction technique used and of water transportation mechanisms they used. Just this table shows the length of ancient aqueducts from the world. The longest now, 94 kilometers, the longest section is really the Gadar Aqueduct. Second one, which until recently was considered the longest ancient world aqueduct, was Bologna in Italy for 19 kilometers only. And this is 94. One section, it's 170 in total. So this 170-kilometer pipeline was constructed with what we call Canad Technology. It's really the technology used in order to build that amazing system. I'll show you a video at the end of this presentation, just a 2-minute video. It will explain this Canad technology, how they manage really to dig this vertical shafts and then connecting them with horizontal tunnels with a slope. And the second amazing thing, how they could really manage to transport water all that distance, okay, using gravity alone. There was no water pumps, nothing. So they managed by really a very well-articulated and well-designed system. As you can see how they can overcome when you have a terrain or you have valleys or mountains. They managed to build a system that really ensured a very steady and easy flow of water. When they faced with the lowland, they intervened with conduit. Sometimes they carried their channel system on bridges, and sometimes they built tunnels. So they combined many elements together in order for this water to run smoothly, okay, by gravity alone. It's a lot of engineering here, a lot of calculation as well, especially with the slope, with the water pressure. You know, we can really give an hour presentation on that system. I will show you this video. Will you drag it here?
Jordan.
Enlarge it here.
Decapolis was a group of 10 cities on the eastern frontier of the Roman Empire, where Jordan is today, and was founded by the Roman general Pompey in 64 BC. Gadara, a city of the Decapolis, was supplied with water through an ingenious Roman network of underground channels, discovered as late as 2004 by Matthias Döring, a German hydromechanics professor. The network included tunnels distributing water to private and public buildings, such as public baths and luxurious nymphaeums, monuments to the spirits of spring water. In addition, fresh water was supplied to the inhabitants of the ancient city of Gadara, near today's Kais, with its 50,000 population. With a length of approximately 170 kilometers, this colossal network of water channels exceeded by more than 9 times the length of the Bologna Channel, which is only 19 kilometers long, and which was until recently the longest ancient aqueduct known. Partly following the course of an older Hellenistic aqueduct, work started after a visit of Emperor Hadrian in 129 or 130 AD. The aqueduct was constructed using Canad technology. That is, a series of vertical shafts or wells connected underground by gently sloping tunnels. The construction workers, who were most likely legionaries, chiseled over 600,000 cubic meters of stone from the ground, the equivalent of 1/4 of the Great Pyramid of Cheops. The Gadar Aqueduct was never quite finished and was put into service only in sections.
That since its discovery in 2004, it was closed because of ventilation problem, because of rubble and some damaged parts. So that was not really easy to get into the tunnel. Until 2 years ago, when Yarmouk University got a grant from ambassador funds, and we managed really to conserve and rehabilitate about 1/2 kilo, which is the aqueduct under the Kais, the Gadara Acropolis. So this is now for about 500 and something meters. It's open for visitation. So if you care about adventure tourism, next visit to Jordan, you are welcome to come and visit the aqueduct. It's amazing, really. So they used it for water, yes, but also for military purposes as well. So there's a lot of studies and still going on this amazing feature. Just to add to the attractions of Case, Gadara is a lovely city in the north with monumental archaeology, but now we have this aspect, the aqueduct, which can really add another dimension, just another dimension to the tourism and visitation and enjoyment of Case. Thank you very much.
So we have just a couple of minutes for some questions. Some of you here may have them. I'm looking on the chat line and I don't see any at this point. Anybody here have a question? Yes, Chang, I will repeat it.
Sure. Super. Thank you.
So the question has to do, or the comment has to do with the discovery in the Divan Plateau, which is north of Petra, getting up near to Madaba, Jordan, of at least 100 hydrological dams. Nabatean, all of them Nabatean? Right. So some may be a bit earlier. Right. You're suggesting more for agricultural purposes. Right. Okay, please.
Well, this is a good piece of information, but I know that they used water for, domestic use and for recreational use, and also for the caravan, city need. But also, yes, I agree. They developed some innovative, even agricultural practices using the water. So they have enough water, not just for their own use, but also for agriculture as well. And knowing, the amount of rainfall in Petra, you can imagine how efficient their water management system was. They collected literally every single drop of water. And above all, they protected their city, which we failed today with modern technology. We failed today to protect Petra from flash floods, but they managed. So I hope that one day this really engineering feat, what we call it, can be reconstructed to protect the city and just to be another monument of Petra, because it's really, a lot of value and significance associated with that system.
So how much difference did it make that the Nabatean water diversion channel at the head of the Sikh, before you're going down toward the treasury, how much did that water system, that tunnel,
Absolutely.
Water? And have we learned anything today?
Yes, what they manage is really to slow down the acceleration of water, to do this step-by-step, system of dams, cisterns, reservoirs. They collected water and they slow down the acceleration of water before it gets to the city. So when it gets to the city, it's just, easy to control and manage. And today, you can, just if you check with this flash flood incidents, people were, it was sunny in Petra, people enjoying the time in Petra, and suddenly, all of a sudden, in no time, you have, the flash floods coming, and people have no time even to escape with their lives.
The flash flood actually happening quite a long ways away.
Yes,
coming
in the mountains.
Skies, right.
Yes, and this is why when I was in a committee about conservation of ancient Nabatean system, I insisted of working from up in the mountains. Started from where the Nabatean really started their system. And unfortunately, I was not able to convince the committee. So they started of rebuilding some of the dams near the sea. And just for the first flash flood, you know, the city was full of rubble of these newly constructed dams.
Any other questions? Do we have questions here? Yes, please.
Are you referring here to what the Gadar Aqueduct system or to water harvesting?
Yeah, I wondered how the current system in Iran, which is still in use many places, will compare.
So the question has to do with a comparison between how you described what is at Gadar or Khais with Iran. And you're talking about ancient,
Still in use today.
but still in use today in Iran.
I really have no information about this Iranian system, but I would think that this Gadar Aqueduct is an amazing, you know, system in terms of engineering and hydrology. And I hope that present-day Jordan can learn the lesson from our ancestors, you know, doing all and creating all these sophisticated water management systems, but we still, in the 21st century, we still suffer the scarcity of water. So I will look at it, Larry. I really have no idea about this Iranian system. Is it similar to Gadara? But with that scale, you know, with that distance? But, you know, in the literature, they only refer to the aqueduct system that I mentioned, you know, the Bologna, which is a Roman time, and then this one. So
I have a question from Maggie, who put this into the chat box. Is the aqueduct being excavated currently? If not, are there any future plans to do so?
Partially excavated. So we excavated the part under the Acropolis of Khais, excavated and conserved and rehabilitated, and then open for visitation. So we have, yes, a plan, if we got some financial resources, to continue, at least to take it, you know, like a couple of kilometers more. So it has to be done in stages. So this is really a very costly and very challenging project.
I have one more question from somebody you know who lives on the other side of this country, your son, who asks about whether you talk about, and you won't have a lot of time to go too far with it, but if you talk a bit about religious tolerance that has been part of basically Jordan's DNA.
It is a Jordan DNA.
Through its history.
You have to visit al-Rasas just to see this complex of churches with magnificent, really, especially the mosaic floors, St. Stephen, St. George, and all that complex. And this is a complex dated by inscriptions to the, I think, either the Umayyad or the Abbasid period. So in the height of Islamic period, there was this coexistence and tolerance. And this is really the DNA, as you mentioned. We still, thank God, in Jordan, current day Jordan, we still have that sort of tolerance. So we accept the others, irrespective of their religion, faith, or belief. I think this is a very strong point of Jordan through history and today.
So that would be the fourth part of your lecture, where you talked about the various technologies, but this isn't technology as much as it is humanity.
Yes. So this is out of the scope of this lecture, but if you talk about Jordan archaeology and history, definitely this, I'm doing currently really a research on 2 sites to prepare an interpretation plan for Rasas and for Pella. And in both cases, you really have beautiful, nice themes, nice messages to communicate to the world about the tolerance and acceptance. Look to the Pella and the persecuted Christians who really found refuge in Pella and Rasas, and so many really examples of Jordan tolerance and acceptance, and in the modern history as well, with all of these refugees flooding Jordan with the limited resources, but we are really now taking care of about over 50% of our population are really refugees. Syrian, Palestinian, Iraqis, name it. Yemenis, Libyans, they all found really a sanctuary in Jordan.
Well, we want to thank you for a fine inaugural Winter Archaeology Lecture,
Thank
Dr.
you.
Ziad. Thank you so much.
Thank you.